So this is what primary succession looks like. Now, primary succession, like I said before, always starts at bare rock. Now notice the rock layer all the way through doesn't just disappear, it stays there. That rock layer is always there. But what happens is the buildup of soil on top of that rock layer. And it happens over hundreds of years. So here we go, time in years, we got hundreds of years. And the first organisms that show up are the lichens. The lichens, of course, we talked about before already in symbiosis. They are a mutualistic relationship where both organisms benefit. We have the fungi on the outside, which creates a tough exterior which holds water inside. And then inside where the water is, where the algae live. The algae go through photosynthesis, provide food for the lichens. The lichens provide a home for the algae. Everybody's happy. So the lichens are the first ones that can survive on bare rock. When they die, they break down by the decomposers and turn into soil. Once there's enough soil, we can begin to have mosses. Those mosses are the next stage of development of primary succession. Those mosses die, they decompose, they make more soil. Exactly correct. Once we have enough soil, we can have the herbs and weeds that end up beginning to develop. They die, they break down by decomposers, they make more soil. You got it. So those are all the pioneer stages. The first organisms that are there are the pioneer stages. And then as that grass gets, as the soil gets thicker and thicker, we can have a larger root base, which means that we can have larger plants. And this is how succession takes place. So after we have the weeds, we have grasses, then we have small bushes and shrubs, then we have the pines, hickories, and immature oak trees. And eventually we have the climax community, which is our full forest. And this is different anywhere you go, depending on the biome, depending on the amount of water, depending on the amount of sunlight, depending on the temperatures, etc. So each climax community is going to be different. In the tundra, the climax community ends at grasses, maybe some shrubs too. But there aren't any full-size trees in biomes that are tundra biomes because of the permanently frozen ground that the roots can't get through. But you get the idea. So again, primary succession starts at bare rock and then makes its way to a thick layer of soil that has been created by decomposition and recycling of those carbon, hydrogen, oxygen atoms, those inorganic compounds. And once that soil is there, then it can support more advanced life or advanced plant forms that have larger, deeper roots. So bare rock is covered by lichens and mosses. They die, they get broken down by decomposers to make thin layers of soil. That thin layers of soil then allow for grasses and weeds to begin to grow in small amounts of that soil. They add organic matter as they die, break down, are broken down by bacteria, make more soil. Brushes and shrubs, like we talked about, as the soil deepens, it can begin to grow more deeper rooted organisms. And those leaves fall off the bushes and the shrubs. They break down, they make more soil. I'm just repeating myself. You guys get the idea. Until finally we end up with a climax community. So, where do we get bare rock from? Well, one of the ways we can get bare rock is from a volcanic eruption. That lava covers and destroys any material that is in its path. Excuse me. And as it covers that stuff, as it covers the plants, it kills them, it destroys them, it cools, it forms new land, it forms new rock. So in order for it to have any kind of new organisms living on it, it needs to go through primary succession. So here's a picture of lichens on rock, bare rock. This is the beginning of those pioneer organisms. Those lichens grow, die, eventually get washed away, or they get washed into little areas. And those little areas collect that soil, and now we can have weeds and other organisms growing in that very small amount of soil. You can also see the rocks all around have lichens on them. As long as those lichens continue to grow, die, eventually that rock will begin to be able to cover and grow more organisms on it. Here we have a picture of a landslide that has taken place that has actually pushed and destroyed all of the area around it, the tropical fern forest, the climax community around it. And now we have new organisms that are growing up in between the rocks. Now you might say, but Mr. Mox, I thought we needed lichens on bare rocks and then mosses. You do, except for the fact that what is all around this rock slide? Think about it. Wait for it. There's already good soil that is around this rock slide, which means that when the wind blows, it picks up soil that has been released by the rock slide. The soil and seeds end up falling into cracks. The plants are able to grow in those cracks. Eventually they will die, make more soil through decomposition, and eventually this bare ground will turn back into a tropical fern forest by primary succession. Continuing on, bare rock, more succession happening as ferns begin to grow in this area. As the soil builds up from the decomposition, larger plants are able to move in and continue to develop and go through that succession process. Believe it or not, our structures that we build can go through primary succession. Here is a church made up of stone. In this case, the ivy is actually eating away at the stone mortar and able to survive, and eventually this church will fall to the ground. That stone will be eventually covered by plants and eventually turn into, as long as with stone wall as well, eventually turn into a forest. If we were to leave, or the humans were to all disappear today, in hundreds and hundreds of years from now, there most likely wouldn't be much evidence that we were ever here, because the plants would take over what is theirs, that what we have taken from them. Now, here you can see primary succession as well. Basically, these are early grasslands that are found at the base of the Kaplan volcano in New Mexico. So here you can see where the lava ran right through the valley and destroyed all of the plants. Since then, it's been making a comeback, and right now we have grasslands, and you can see that some of the mature forest is beginning to sprout up in these areas as it continues to go through primary succession. Now, this is an example of an area that has been cleared either by humans or by a natural disaster that was not a volcano. And you can see that this area is already returning back to its normal process. The soil is already present. You're already getting small trees that are growing, etc. Here we have some pines, I think, right here that are growing. And you also have grasses and other species of plants. All of that is the process, because soil is already present, of secondary succession. And eventually, both primary and secondary succession lead to a climax community. In this case, the California redwoods that I have borrowed a picture from the internet for. These are mature, stable ecosystems that are able to thrive through normal processes and will stay that way unless acted upon by a natural disaster or an outside force such as humans. Secondary succession occurs after a community has been cleared because of a disturbance, either natural or artificial. Those natural disturbances include earthquakes, include hurricanes, anything that isn't creating new rock, more or less. Fire, deforestation, that's artificial, of course. Secondary succession is much quicker because, most importantly, There's soil that's already there. Second, there's an existing seed bank of suitable plants already in that soil as well. There's a lot of root systems that are most likely undisturbed underneath the ground. Stumps and other plants from previously existing can rapidly regenerate and regrow that forest. The fertility and structure of the soil is also already been substantially modified by previous organisms, which makes it suitable for growth and colonization. Secondary succession occurs after human intervention. To the left, you can see a controlled burn. It's burning the stuff that has fallen down, the materials that could ignite. What on the right is a fire that's out of control, a natural disaster, a forest fire. If we keep those ignition points low, or we keep that material on the ground so it doesn't build up a lot, it keeps those fires from getting out of hand and turning into natural disasters. But once that fire moves through, fire is actually a natural process for forests, and it actually basically recycles a lot of those carbon, hydrogen, oxygen atoms, puts them back into the ground, makes the ground ready for repopulation. Now, what's interesting is some plants are fire ready. Pine trees release pine cones, and those pine cones don't actually open until 140 degrees. Well, obviously on a normal day, you're not going to get 140 degrees, but when a fire comes through, you are going to get those high temperatures. Those pine cones open up, release their seeds, and notice the first organisms that are making their way out of that after a forest fire. There's a whole bunch of ash here, but we have baby pine trees that are all growing up first. Secondary succession takes less time to reach a climax community since pioneer species are not needed and the soil is already present. That's the difference between primary and secondary. Here you can see just a set of pictures moving from a glacier, which is basically rock and dirt, and then eventually, as that glacier retreats, moving into a climax community of pine forests in the bottom right-hand corner. If you haven't subscribed, please subscribe. This is the end of our succession notes. Pretty quick and easy. Let me know if you have questions. Have a good day.